Hello, today's video is going to be talking about trigonometric ratios, sine, cosine, and tangent. We're just going to be continuing what we started to talk about today in class. Make sure you have not only paper and pencil to take some notes, but also your book, and you might want to open it to page 845, and a calculator. Really, you need either one or the other, either the book open to page 845 or a calculator that has sine, cosine, and tangent on the keys. All right, so let's get started with sine. Sine is spelled S-I-N-E, but we always see it abbreviated S-I-N, and that is how it's going to show up on your calculator as well. You're going to be looking for that S-I-N button. All right, the definition of sine. The definition of sine is that you have opposite over hypotenuse. Let me erase that for you. So if I have an angle, we'll call this down here angle A. Our right angle is here. So angle A, the sine is going to be the side opposite. So if I go opposite that angle, that's right here, over the hypotenuse. Okay, so whatever this side is over the hypotenuse. If I want to talk about if angle A is up here, let's move angle A. Then the side opposite this angle is down here. So where opposite is depends on the angle. The hypotenuse is always the hypotenuse. Okay, so make sure you pay attention to where your angle is. Okay, the next one we're going to talk about is cosine, again spelled this way but abbreviated this way on your calculator. So the cosine of an angle is the adjacent side over the hypotenuse. So if angle A is up here, now remember before we said this is our opposite side, so cosine does not use the opposite side. We know this is the hypotenuse, which never changes. So this side has to be the adjacent side. It is the side that is next to and actually forms a part of the angle we are looking at. Okay, so adjacent means next to, so there's our adjacent side. Again, if we change the angle that we're talking about, so if this is angle A, now our adjacent side is down here, and we would use adjacent and hypotenuse to find the cosine. The last one we'll talk about is tangent, an abbreviated tan on your calculator. The tangent is the opposite side over the adjacent. So again, we have our right angle here. If this is angle A, we know this side is opposite, and we know this side is adjacent. Tangent is the one that does not use the hypotenuse. And again, if we flipped these around and made that angle A, now we have the opposite side here and the adjacent side here. All right, let's look through some problems and hopefully that'll clear up any questions you might have. All right, so in summary, we have three trig functions we're going to work with: sine, cosine, and tangent. Each one of those are in a ratio: opposite over hypotenuse, adjacent over hypotenuse, or opposite over adjacent. An easy way to memorize that is SOHCAHTOA. SOHCAHTOA just takes our sine and makes it opposite over hypotenuse. Cosine is adjacent over hypotenuse, and TOA is opposite over adjacent. So you can use this kind of Indian sounding word, SOHCAHTOA, in order to remember which side goes with which ratio. All right, so first example, let's just see if we can set up some ratios. First, let's find the sine of A. So we are working with this angle right here. Let's highlight that. So we want to first, if we remember our SOHCAHTOA, we are going to first to find sine, take opposite over hypotenuse. So the side opposite angle A is 4, and the hypotenuse is 5. Let's put our right angle in there. The cosine of A is adjacent over hypotenuse. So adjacent to A is 3, and the hypotenuse is still 5. For tangent, we're going opposite over adjacent. So opposite is 4, and adjacent is 3. And we can go ahead and leave them as a fraction, or you can find the decimal. This would be 0.8. 3/5 would be 0.6. And 4/3 would be 1.3 repeating. Okay, now let's look at a different angle. So now we're looking at side B, or angle B, excuse me. So we want everything in terms of angle B. So when I go to find the sine, opposite over hypotenuse is now 3/5. Adjacent, or next to, is 4/5. And tangent is opposite over adjacent, so 3/4. So again, we have 0.6, 0.8, and 0.75. Now if you compare sine and cosine of both of these angles, notice that sine and cosine switched places when we switched angles, and the tangent reversed. So it was 4/3, and now it's 3/4. So it's the inverse. Okay, again, we're going to compare the sine, cosine, and tangent. We're just going to do angle A and angle D of each of these. So we're just going to look at those two angles. So if we find the sine of A, that's equal to, if I go opposite, that is 5/13. And I can go ahead and find that decimal, just divide 5 divided by 13, and that's 0.3846. If I find the cosine of A, that is adjacent over hypotenuse, and that decimal is 0.9231. Tangent of A is opposite over opposite over adjacent, so I have 5/12, and that is 0.4167. Now I can go over here and find the sine of D, and that again is opposite over hypotenuse, so 2.5/6.5. And when I divide that, I get 0.3846. Cosine of D is adjacent over hypotenuse, and I get 0.9231. And tangent of D is opposite over adjacent, which is 0.4167. So you can see these are similar triangles. All of their sides are in the same ratio, and all of their tangent, or their sine, cosine, and tangent ratios are the same as well. So these are similar triangles. All right, so how do we find sine, cosine, and tangent? Very easy. You can either use your calculator, or you can use the table on page 845 in your book. This particular table I found online, so you can also Google sine, cosine, tangent table, and you can also find it there if you don't have your book. So if we're going to use the table, we just want to look at sine 56. So we find on this table the degrees are over here, so I'm going to go down and find 56, and then I want the sine value, so that's this column, and I look where those meet. So the sine of 56 is 0.8290. Now I can also use a calculator. If you have a graphing calculator or a lot of the scientific calculators, you want to make sure that you have your calculator in degrees. So I'm going to go on a graphing calculator, and if you haven't used it yet, you may need to check this. You're going to go second and mode, or excuse me, don't do the second, just hit mode, and this menu will come up. And you'll notice that the third choice down says radians and degrees. You want to make sure that the degrees is highlighted. So arrow down and then arrow over and just hit enter to make sure that your calculator is in degrees. Other calculators you want to look at should say a little DEG on the screen to make sure you're in degrees. If you are getting the wrong answer when you do some of these, that's probably the reason. All right, so once you have done that, now we're going to go ahead and quit out of there. And we can type in sine 56. So for this particular calculator, I hit sine first, 56, and then hit enter. And you notice it says 0.8290, which is what we found on our table. Okay, we can also find the tangent of 66, so let's go ahead and do that. So I'm going to type tangent 66, and I get 2.2460. So let's go ahead and write that. We can also find it on the table. So if you're using the table in your book, you're going to look for the 66. This time we're looking at tangent. And so there's our value right there that we also just found on the calculator. So we have 2.2460. And last, we want to look for the cosine of 63. So I find 63 on the table. This time I want cosine, and it's different books will have it in a different order, so make sure you look at the table headings. And again, you could use your calculator to find this as well. And that's all there is to it. So that gives you the ratios from the table or from the calculator. All right, now, well, how do we use these ratios and what do we use them for? We can use these ratios to find the missing pieces of right triangles if we're only given one side. So for instance, if I have 42 degrees down here, I can use my trig ratios to find u and v. Now I'm given 15, which is the hypotenuse. So I want to use a trig ratio that uses the hypotenuse. So I'm just going to go ahead and use sine. So the sine of 42 degrees. Now remember that sine is opposite over hypotenuse. Okay, so I'm going to take opposite 42, which is u, and the hypotenuse, which is 15. Then I'm going to use my calculator, and I'm going to find the sine of 42. So I'm just going to type in sine 42 and hit enter. And that is 0.6691. And now I can just solve this problem. So I'm going to take 15 times 0.6691, and you can just leave it in your calculator, don't round it, just take it times 15, and you will get 10.03. So that is side u. To find v, I'm going to use the cosine ratio. So cosine of 42 is equal to V over 15. Cosine of 42 using your calculator or the table is 0.7431. Go ahead and multiply both sides by 15. And we end up with 11.15. Okay, so that is how you use trig ratios to find missing sides. Let's look at one more example. All right, again, we know we have a right triangle, so we can use our trig ratios. We're going to use the 65 degrees. This time, the side we know is opposite. So whatever trig ratios we use, we need to use those that include the opposite side. So I know I have SOH, CA, TOA. The two that use opposite, because that's the only side I'm given, is sine and tangent. So those are the two that I'm going to use to find the missing sides. So let's start with sine. I know the sine of 65 is opposite over hypotenuse. So this is a little different with our variable in the denominator. What we want to do is basically, if we go through all the math, they would just switch places. So what I'm going to do is take x equals 8 over the sine of 65. So you can plug that all into your calculator at once, or you can find the sine of 65, which is 0.9063, and that's going to equal 8.827. Now I want to find y, so this time I'm going to use tangent, because remember that's the one we have to use that has the opposite. So tangent 65 is opposite over adjacent. And again, they're going to switch places. And I can look up or use the calculator to find tangent of 65. And so I will have 8 divided by 2.1445, which is 3.73. So that's how you use sine, cosine, and tangent to find missing sides.